Time to talk about the second type of ionizing radiation, the beta particle. The beta particle is a little bit more complicated to explain because in the case of lighter nuclei, when there are too many neutrons, one neutron can turn into a proton inside the nucleus in order for it to become stable. In the process of doing that, it releases a high-speed electron, and that high-speed electron is the beta particle. The electrons have a charge of -1, and the mass of the nucleus does not change during this type of decay. So the example I've got here is a classic form of beta decay. Now this is the decay equation for beta decay that you need to be aware of. If you look at the top line, the mass numbers do not change whatsoever. So the carbon 14 turns into nitrogen 14 here. The beta particle, that symbol on the far right hand side, is represented with a 0 on the top because the beta particle is considered to have no mass or negligible mass. It's sometimes referred to as being 1/2000th that of a proton or a neutron. In terms of the atomic number, you can see that the atomic number goes from 6 to 7. That's the representation of this neutron turning into a proton. But because they stay inside the nucleus, the mass number doesn't change, just the atomic number increases by 1. In order for that to balance, the beta particle is given a -1 as an atomic number, purely to make sure that the left-hand side of this equation matches the right-hand side. Properties of this beta particle. Now, a beta particle can be shown with the Greek letter beta or with an electron, a lowercase e for electron. Mass. So roughly, like I said, 1/2000th that of a proton. In an exam, you are safe to say that it has negligible or no mass. In terms of its penetration ability, it's moderately penetrating. It can travel a few meters through air, but it will be stopped by a few millimeters of aluminium, and that is linked into its applications, which we're going to talk about in the near future. Ionization wise, it's moderately ionizing. Its negative charge and its speed mean that if it was to collide with other electrons, it's got a good chance of transferring enough energy for them to escape the atom and therefore make an ion. Speed-wise, they're faster than alpha particles. You need to know comparatively they are faster than the alpha particles. You also need to know that because they have a light mass or no mass, then in comparison to the alpha particle, they will change direction in the magnetic field in the opposite direction and more rapidly. So it would be a much tighter curve on the electron than it would the alpha particle, and it would be curving in the opposite direction to the alpha particle. The main application of beta particles is directly linked to their penetration ability, and it makes them very useful for thickness control. If too much radiation gets through, the rollers get separated, and what you end up with is it separates, and as it gets thicker and thicker and thicker, less and less radiation can travel through the material. So this is typically done with either paper or very thin sheet metal that they're trying to control the thickness of. As it gets thicker and thicker and thicker, like I mentioned, the amount of beta radiation that can actually penetrate through to the detector drops. When too little radiation gets through, the rollers can be moved closer together to each other, so again allowing more radiation through, and when the detector can sense the correct amount of radiation, it can stop adjusting backwards and forwards the two rollers, and that is the primary application for beta particles. Key things about beta particles that you need to be aware of. A beta particle is a high-speed electron released when a neutron turns into a proton inside that unstable nucleus. After the decay, the mass number of the nucleus stays the same, but the atomic number increases by 1, representing that change from a neutron to a proton. It has almost no mass or negligible mass. It's faster than the alpha particles. It's moderately penetrating. It can get through a few meters of air or up to about 5 millimeters of aluminium. It is stopped by thick aluminium or anything beyond that. It's moderately ionizing. It's deflected in the opposite direction to alpha particles by a magnetic field, and it is deflected more rapidly by those magnetic fields. Beta particles are used in thickness control. That's their main application.